Hi everyone. Today we are going to understand one of the most basic but extremely important interview questions, that is reverse string. This looks simple, but interviewers use it to test in string fundamentals, two pointer thinking, time and space complexity awareness. So let's break it down in the simplest possible way. So reverse a string means rearranging its characters so that the last character becomes first and the first becomes last. Example, I have an input hello and our result or output should be O L L E H. Correct? So this is our result or answer we need. So first let's start with the most basic method, that is the brute force approach. So in the brute force approach or a simple method, what we do, we create an empty string and then we loop through the uh, strings, and we in the loop we will concat to the result one by one and will return the result string. So let me write a code for that to better understand. So let me create a static string reverse method which takes string parameter or argument we say, and in this one I will initialize empty string to store the result, and in the loop I is equal to s dot length minus 1, I is greater than equal to 0, and I minus minus. This is our for loop. So in the for, on every iteration we concatenate the character with the result and return result. Correct? So what we are doing, we created a new empty string, then we are we go from the end to the beginning and keep adding characters. Correct? So this looks fine, but here is the problem. In C# strings, in C# or Java, strings are immutable. That means every time we do results equal to results plus s of I, a new string is created in memory. So if the string length is n, we copy characters again and again. So in that case our time complexity becomes O of n square. For small input this works perfectly fine. For the larger input this code will be very slow. So next, what interviewer will look for? Optimized version. They usually look for the optimized solution. So we'll go for optimized solution. That is we can say two pointer approach. Correct? In this we use two pointers, one at the start and one at the end. Like for example, I have a hello here, right? So this is my left pointer and this is my right pointer, and this index is 0. Correct? And this is 4. Correct? So in the first iteration, let me write hello again. So this is 0 1 2 3 and 4. Correct? So in the first iteration, what will happen? Iteration 1. So swap H with H and O. Correct? In the second step, swap E and L. Correct? And stop when left pointer is greater or equal to right pointer. This is our logic or algorithm, we would say. So now let's code it and we'll see. So same again, return type is string and method will be a reverse string. Correct? And it will take the single argument string. Now first we'll check if string is null, then return null. Correct? And first we'll take the character array equal to, so we'll convert our string to array of characters, I would say, using inbuilt function. Initialize the left pointer with 0 and right pointer with our array of length -1, and we will use the while loop, whereas I said earlier left pointer is less than right, then execute the logic. We'll take the temporary character for storing. If array of, here we writing the swapping logic, so we store array of right and array of right equal to temp. So we done with our swapping logic, and for every iteration our left pointer will be incremented and right pointer will be decremented. And once we done with the loop, we return our new string. So let's analyze our code, what we did here. So our time complexity here, O of n. Each character is swapped only once, because we convert to character array here, and that's the reason our space complexity is O of n. And if language allowed mutable strings, then it could be, space complexity would be O of 1. So now with this code we can dry run. For example, we'll take a input as code, code. This is the input string 0 1 2 3. So our left is 0 now, correct, and our right is 3. Now first iteration, what happens? Our left is equal to 0 and right equal to 3. Now swapping logic will execute. If you see here our swapping logic, so array of 0 will be into temp, and array of right, whatever available in the right pointer, will be push it to array of left, so that will be here, and temporarily the C will be moved here, correct. So in the first swap, C and E, correct, and our output would be E O D C, correct. In the second iteration, our left will be incremented to 1 and right is 2. It is decremented. Now swapping logic will execute again, and we swap O and D. So our result will be E D O C, correct. Now left is equal to 2 and right is equal to 1. So here we stop, because in the while loop condition, if his left is lesser than right, then it won't execute. So result will be EDOC, correct. So when you see any reversal or symmetry problems, so we can use a generic template like this in the interviews. So left, just I will write for your reference, left and right equals to, these are the pointers, and we use while loop where left is less than right, and swap left comma right. So we need a swapping logic, and you update the pointers. So this is what we need, patterns in solving the or checking the palindrome, reverse words, valid palindrome problems, container with most water, many two-pointer problems. So we can use this generic template, so we can easily remember this one as well. And even when you go to interview, so we can easily, if they ask you reverse a string, so you can easily say I would use a two-pointer approach, and I convert the string to a char array and initialize the left and right pointers, and I need a swapping logic for the characters. So yeah, and this gives a time complexity of O of n, and space complexity would be O of n. So that's all we learned in this problem. Thank you.